Okay, today's quiz, people got a good start on it, considering nobody did the, no, one person did the Milton math assignment, okay? And that person's work here looks fairly good. What we did in class last time, though, we're gonna follow the procedure. So I'm gonna draw this line, then I'm gonna draw this fundamental triangle. And I might as well draw it here, I'll regret it later. And we draw arrows on the fundamental triangle. If you didn't have arrows in the fundamental triangle, there's a good chance you made an error, but I'm not sure I saw anyone really. I wasn't really looking for it. But you want the arrows. You want the arrows to indicate two possible paths from this point to this point. So this arrow, this path would go here and here. This path would go directly, okay? You could use the path from here to here, in which case all the arrows would be in the opposite direction. You'd get the right answer either way, okay? But usually we go left to right. It's kind of a convention, so that's the way I'm going to do it. It's not wrong if you do it the other way, as long as you keep the arrows right, okay? So, whatever this side is, that's the rise. And that equals, well, you're going from -4 to 0, right? Now you know that's a rise of 4. It's positive. But we calculate it. We write out the calculation because you're going to have to be able to do this in symbols. And in symbols, you don't know what this is, or the displacement. Okay, so this is 0 minus -4. Okay? Can you see okay, Katie? Now that the board's a little drier? Okay. And that's 4. And of course that agrees with the picture. And then the run is from 0 to 6. Well, here's the 0 coordinate, here's the 6. We do 6 minus 0. Okay. So if we look at the coordinates, we're doing 0 minus 4. We're starting here and ending here, so we do this minus this. Okay? Where we end minus where we start. And the same with the x coordinates, get the run. Straightforward. And then the slope is rise over run equals 4 over 6, which is 2/3. And so we can easily find it. If we got this picture, we put the 2/3 here with a box around it. That's a convention I use. But if it's there in your paper, you don't have to go looking for this calculation if you come back to it, okay? It's right there. You see everything you need. Okay? So now, the equation of the line y equals mx plus b, where m is the slope and b is the y-intercept. The y-intercept is -4. So if you know the two intercepts, you can easily work out the equation of the line. And that's simplified. Y equals 2/3 x minus 4. Now I'm going to do something a little more that's worth reviewing the videos and stuff. Make yourself a note. Kind of new, coming along about 5 minutes into the video. Try that part. Let's say we go out to this point here on the line. I want you to estimate the x-coordinate or the y-coordinate to that point. Don't estimate both coordinates. We did that last time. We estimated the two coordinates and we plugged them in here. And we didn't expect the sides of the equation to come out exactly the same, but we did expect them to come out kind of close. All right? And for the most part, they did. And some of your estimates worked out even better than mine did. Okay. Right now what we're going to do is we're going to estimate what the y-coordinate is here and use that with the equation to figure out the x-coordinate. So I want you to do that. Now, I say use it to find the x-coordinate. Well, I'm asking you to kind of do a two-step thought process. I'm going to make it a little easier on you. We want to estimate the y-coordinate. Plug into the equation. And solve for x.